Hey, you made it to 10.5. It's the last lesson of the unit. Here's your joke of the day. What is the best way to get in contact with a fish? Drop it a line, naturally. Okay, here's the beautiful thing about this situation is that I'm going to simplify this lesson a ton based on what I would have had you do on paper assignment because the math space assignment is 100% multiple choice. You are welcome. Okay, so here's what you're going to do. Basically, 2-column proof. It's very similar to everything we did in 10.4, just like determining if triangles are similar, but this time we're just going to be writing out our reasons of why we know. That's all that's happening here. And so before we jump right into that, we need to talk about just a few definitions of properties that we need to write these proofs. And, you have this big table of properties. Well, guess what? You don't need some of these now that we're simplifying things. So I don't need that one. Let's see. I don't need these two. Look at that. There's only 5 properties that we need to know. Okay, so I actually want to start with the angles because we talked about these last time. Vertical angles. Here's what's going on. You got like an X of lines. And this is just what we know. Vertical angles are congruent. Okay, that's all that happens with this one. With corresponding angles, this happens when we have parallel lines. And we mentioned this one last time as well. This would be, here's my parallel symbol. This would be 2 angles that are in the same spot or corresponding spots between the 2 lines. So see how that's like right angle up top, right angle in the middle. And so we know that corresponding angles are congruent. Okay, and then we have alternate interior angles. This also happens with parallel lines. Same thing here. So alternate meaning they're on alternate sides of that transversal here. This line that it's cutting is called a transversal. Alternate sides, interior meaning they're inside the parallel lines. So there's congruent, there's congruent. Alternate interior angles are congruent. Okay, so that's all the angle stuff, and I'm really hoping that's familiar to you. So the only other 2 properties that we're really going to need here, so we have the substitution property. This would be like, we're basically replacing a quantity with a name. So this also means that I can plug something in for something else, substituting something in. So if I know that JK is equal to 5, and I have 5 over 7, well, later I can call that JK over 7. That might not make sense right now as to why we're going to use it, but the next page, it'll make some sense. The reflexive property, this one's also going to be used quite a bit. This is that, this is saying that something can equal itself. So this would be angle J is congruent to angle J. We know they're congruent because they're the same angle. That's the reflexive property. So basically, we're just going to pull together all of these properties and we're going to use them to elaborate as to why we know that triangles are similar. So here's the big thing with two column proofs. Kind of wrote it all out for you here. The first thing is, what do you know before you start any of the math? That is what we call the given information. And so it's like, okay, before I even start the problem, what do I already know? And I just want you to kind of go through this process. You know, can I show any of the angles are congruent? Can I show the side lengths are proportional? And then what is this? Is it angle, angle, side, or side, side? And that's just going to be kind of our 4-step process as to how can we do things here. Once again, bolded, nothing different is happening than what you did in 10.4. Okay, so the first thing you should list in any two-column proof is the given information. So what do I know before I start any of the math? Okay, I'm looking here at number 1. Well, before I start the math, I see these symbols. That means that those lines are parallel. So here's how we're going to write this. We're going to say segment KL is parallel, and that's the symbol for parallel, to EF. And how did I know that? Well, I knew it by looking at the picture, which meant that it is a piece of given information. Okay, I want you to think back on 10.4, and is this going to be an angle, angle, side, or side, side? Which one do you think it will be? I'm hoping you said angle, angle, because none of my side lengths here are labeled. And, you know, even looking back at this step 2, can I show any of the angles are congruent? Well, we have a few different approaches for this with these parallel lines. The first thing that I want to point out is, just so you're used to what the reflexive property would look like, you see how we have two triangles here? We have the big one and we have the smaller one. You know, we have KLJ and we have EFJ. Well, hey, angle J is itself, because it's the same angle in the two triangles, and we know that by the reflexive property. Okay, can I show that any other angles are congruent? Well, let's look what we could use with parallel lines. It was either corresponding angles or alternate interior angles. Well, these are in the same spot between the two groups, so I know that angle K is going to be congruent to angle JEF. And you might be going, hey, Miss Lambert, why did you put three letters on that one instead of the angle K? Well, if you look, K is only referring to one angle, but angle E, am I referring to that side, or am I referring to this side? And so that's why I was a bit more specific with that one. So angle K is congruent to angle JEF because those are corresponding angles. And because of this, well, I just used some angle-angle similarity. And so I'm just going to write this similarity statement that started over here. So triangle JKL is similar. JKL is similar to JEF. Triangle Jeff by angle-angle similarity. And that is how we do a two-column proof. I'm hoping that wasn't too bad for you, and I think, like, especially with just multiple choice, I think you'll be okay. Let's do another example here. Okay, prove the two triangles are similar. Here's something you need to know with similarity, and this is important, so I'm going to write it in red. Basically, to show that sides are proportional, like, we're going to have to set up proportions. And so here's what I got going on. If I know that triangle ABC is similar to triangle DEF, then I need to be able to set up a proportion of side lengths based on these corresponding sides. So remember, I have AB goes with DE. So this shows me that AB over DE is supposed to equal BC over EF, which is also supposed to equal AC over DF. That's our definition of what proportional side lengths look like. And so, well, the first question is, do I know anything by just looking at the picture? Well, I know the side lengths. I'm not going to make you write those down. Next step of our two column proofs up here. Can I show that any of the angles are congruent? Well, I see here that I have some vertical angles. And so let's just name those. I'm going to have to use the 3 letters for each one to, just decipher which side of angle K I'm going for. So I can say angle QKP is congruent to angle MKL. Those are vertical angles. And now we're just going to show that the side lengths are proportional. So once again, we need to go largest to largest. So 156 over 65. And then it's going to be 84 over 35. And so we're going to check that in our calculator to see if those are equal. 156 divided by 65, that's a 2.4. Oops. Okay, 156 over 65 equals 2.4. 84 over 35 is also 2.4. So those are the same. Well, how did I know those were the same? This was a box that maybe I shouldn't have had you cross out. It's division. And pretty much just be safe to say we always put property after it. But I knew those were equal because I divided. Therefore, we just call it division. And then we put property after it to make it sound fancy. Okay, well, remember, we have to use the actual side length names to specifically prove and show by definition that they are proportional. So this is where substitution is going to come in. Because I'm going to substitute a name for a quantity. So for example, 156 is side length KL, 65 is QK, 84 is KM, and 35 is KP. It doesn't matter if you wrote it as like PK or KP, like the sides, they're still the same. So here's what I know. Which similarity theorem did we use here? I have an angle between two sides, so that is side angle side similarity. And so now we just have to line up the corresponding sides and angles. So I'm going to start with here, K, down the long side, go nothing. So KLM is similar to triangle. This is legit how I do it. I said I went down my box here, so I'm going to go down my box from there. KQP. And then we have the side angle side similarity. So here's a tip in red for you. Division and substitution will always be used together. There's no point of using division unless we're going to substitute in the names of the sides. Okay, last example for these notes. I'm hoping you can guess right now between angle, angle, side, and side, 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 which one we're going to use. I know nothing about any of the angles here, so we're going to I know my target is going to be side, side, side. So we're going to go off of this idea again. So I'm just going to pick my largest side is 42. My largest side over here is 28. My next largest side on top is 39. The next largest side below is 26. And that leaves 33 and 22. So we're just going to check those in our calculator to make sure that those are equal to each other. So 42 divided by 28, I get 1.5. 39 divided by 26 is also 1.5. 33 divided by 22, also 1.5. So all of those are the same. I knew that because I divided the numbers, which means that I used the division property. Well, division does mean nothing. Like this tip I just gave you, division and substitution are used together. So 42 represents side DE, 28 represents side UV, 39 represents DC, 26 represents VW, 33 is side CE, and 22 is side UW. And that's where we use substitution. And so if they give me a similarity statement to fill in, I usually just go and finish that. So EDC, start E, go down box, and then up the circle. So let's see. So that would match with up the box, down the circle. So triangle UVW. Very technical names here, and we know that by side, side, side similarity. And that's honestly all that 2-column proofs take. I hope that wasn't too complicated for you via this platform, but I really think at least, the math space assignment is just a multiple choice assignment. It's 6 questions long. I really think you're going to be okay. But if you're not, or if you have questions, feel free to email me, and I'd be happy to take some time to answer them for you.